NASA Hunch Lunar Wheels. My name is Matthew Cormier.
I'm Luke DeValcourt.
I'm Eric Brazil.
And I'm Austin.
Our instructor is Mr. Liberto, and this is Beauchamp High School. NASA has shown interest in building or inhabiting the moon, and we have come up with our own personal design of the lunar scooter wheels in order to maneuver the rough terrain of the moon.
So for our research, we come up with possible wheel types like the pneumatic wheel, the Curiosity rover wheel, and the tank tread. Possible material types we have come up with was Kevlar, aluminum, titanium, and pneumatic. And then for my idea was to reinforce the Curiosity rover wheel, which make it more suitable and to withstand most of the moon's atmosphere.
My design was basically taking that of a normal wheel and applying a basic spoke design. I got most of my ideas from the Curiosity rover wheel.
My design was that of a standard snowmobile almost, as it's used to maneuver a similar terrain to what I imagine the moon would be, having the cleats on the treads, a very springy, foldable system.
And my design was a mixture between the Curiosity rover wheel and the pneumatic wheel, just to better uphold against the terrain. So the criteria and constraints of our prototypes were flexibility in the spokes and the 100 pounds of earth weight, last 300 miles in rough conditions, hold up against lunar regolith, and be easily pushed on foot. Some of the constraints were it could be no larger than 18 inches in diameter, no wider than 10 inches, no suspension or motor. It had to have half-inch axles, withstand the vacuum of space, and uphold against high and low temperatures. When we were trying to choose a design, we made a chart and tried to figure out whose best would fit, and we came up with Luke's design.
So for our very first CAD model, we have something very rudimentary. It doesn't have any of the mechanical components. It's just the wheel and the gears. So ideally, we would like it to be made of aluminum and something like Kevlar, which is very strong in resistance and still has some stretchiness to it. For our first prototype right here, we have very simple cardboard outer layer with some Vex parts as our gears. It's held together with duct tape. You know, it's very simple. For our prototype version 2, we wanted something that would last longer than cardboard and would have a better implemented cleat system. So we looked towards a already existing tank tread for something like that. For our materials, we have some 3D printed gears and sprockets. We have foam taken from exercise mat. It's still held together with duct tape. And we have the cleats are attached on there by liquid cement. So for our second prototype, we changed from a simple gear to a sprocket design, which we would later like to implicate a bike chain to help it roll better. On our second one, we used a more durable material. We added the cleats to it so it would better able to dig into the surface. And we have real axle to help it move better. Here's some quick testing of how it rolls. So that is a mixture of sand and diatomaceous earth. It rolls fairly well. There are some spots where it loses its traction, but overall, it rolls well.
Okay, so, this model y'all just built with? or
Yes,
is it
this is our first
That's your first
prototype.
one.
That's the one that was tested.
That's the one that's, that's one of the big. So this is for the front fork or the rear?
The rear wheel.
So what did y'all want to use for the front wheel?
So for the front, on our presentation, we have a snow scooter. That has a sled in the front, all right, that attaches under it. So that's what we were kind of hoping to use.
So somebody talk to the board, so see what all that, tell me all that stuff. is gonna do. And then somebody hand me the book, show me a brochure so I can see what's on that.
Okay. So for our similar designs, we went with the already used snow scooter, which was motorized, but even though we can have, it be motorized in space, we looked at what can be similar to this snow scooter, but allowing us to use a little bit force to move along the surface. So for the tread system, it allows us to get through rough terrains like snow, sand, and it allows it to like adjust itself to meet the surface need, or allows it to push itself through rough terrains.
All right, that's good. I think the concept's good. I think it's good y'all taking the basic parameter and expanded them into, I think wheel, like a perfectly round wheel, right? So I think the scooter concept idea is pretty good. On the inside, so you'll have a drive mechanism that drives the big gear or the small gear, you think? So,
The big gear will be first. This is the third not first.
sort of, are they, is that just like a follower in the back, or in the front's the drive part of it, or will the whole thing kind of work synchronous with,
The whole thing will work together. This is just gonna be in the front.
So the big wheel, the big gear is the part that will attach to the scooter.
and then just conceptually, so that'll be obviously electric, right?
This will actually be pushed by foot.
Off, okay. Ah, okay. I'm gonna ask you how you're gonna drive that gear, but, so it's all foot. Oh, man. So this is the emergency vehicle to get back to the spacecraft.